Hi, in our previous video we have discussed what is meant by a degree of a polynomial, a linear, quadratic and cubic polynomial, and what is the meaning of a zero of a polynomial. In this lecture we will understand what is meant by the geometric meaning of the zero of a polynomial. In the last lecture we understood what is meant by a zero of a polynomial. Now we will try to understand the geometric meaning of the zeros of the polynomial. So, geometric meaning of zeros of a polynomial. Geometric meaning of zeros of a polynomial. So why do we need to go for the geometric meaning of a polynomial? To understand the geometry, to understand the meaning of a polynomial, to understand the meaning of a zero of a polynomial, to understand the meaning of zero of a polynomial, we need to graphically represent the polynomial. Graphically represent the polynomial. So how do we graphically represent it? By taking the points. So initially we will start with the linear polynomial. First we will start with the linear polynomial. So linear polynomial geometric representation. Geometric representation. So for example, let us consider the same polynomial which we have discussed earlier. Consider p of x is equal to 2x plus 3. So here what is the zero of the polynomial? Zero of the polynomial is x is equal to minus 3 by 2. So easily we can able to find what is the zero of the polynomial is. Here the zero of the polynomial is x is equal to minus 3 by 2. This is very simple, but let us try to understand it graphically. So we know this, but we are going to understand it by using the graph. So let p of x is equal to y. So I can write y is equal to 2x plus 3, no, because p of x is equal to y, by considering p of x is equal to y, I can write y is equal to 2x plus 3. Y is equal to the 2x plus 3, that is the polynomial. Okay, fine. So now let us try to plot the graph of y is equal to 2x plus 3. So to plot the graph y is equal to 2x plus 3, we need the points. So we take x here and y is equal to 2x plus 3 here. And we take some random points, say minus 2, minus 1, 0, 1 and 2. So we have y is equal to 2x plus 3. When x is equal to minus 2, when x is equal to minus 2, y is equal to, when x is equal to minus 2, y is equal to 2 into minus 2 plus 3. So, I have y is equal to minus 1. So, we have y is equal to minus 1. When x is equal to minus 1, when x is equal to minus 1, y is equal to 2 into minus 1 plus 3, that is equal to minus 2 plus 3, that is equal to 1. We have 1. When x is equal to 0, y is equal to 2 into 0 plus 3, so y is equal to 3. Y is equal to 3. So, this is also over. When x is equal to 1, y is equal to 2 into 1 plus 3, that is equal to 5. Y is equal to 5. So, y is equal to 5 I have. Similarly, when x is equal to 2, y is equal to 2 into 2 plus 3. So, y is equal to 7. So, I have 7 here. So, we have done all the points. We have done with all the points. So, let us try to plot these points in the graph sheet so that we can able to understand the geometric meaning of it. So, I have a graph sheet with me. Let me plot the points. So, this is the positive x-axis and the negative x-axis, and here it is the positive y-axis and the negative y-axis minus y. So, let this point be. So, let us mark the points 1, 2, 3, 4, 5, minus 1, minus 2, minus 3, minus 4, minus 5. One, 2, 3, 4, 5, minus 1, minus 2, minus 3, minus 4 and minus 5. So, let us mark the first point. So, x is the first point is x is minus 2 and y is minus 1. Let us plot that point. So, x is minus 2 and y is minus 1. So, this is our point. That is the first point. The second point is minus 1, y is 1. So, minus 1 comma 1. So, x is minus 1, y is 1. So, this is our point. This is the second point. And the third point is 0 and 3. X is 0. So, this is our 0 comma 0. And y is 3. So, this is our point, the third point. So, this is our third point. And the fourth point is 1 comma 5. So, x is 1, y is 5. So, this is our fourth point. And finally, the fifth point is 2 comma 7. X is 2, x is 2 and y is 7. So, 2 comma 7 is 2 and so this is 6 and this is 7. So, it is here. Right. So, let us join all the points. So, while joining all the points, it is observed that it is along a straight line. The points are along a straight line. So all the points are along a straight line. So what is the equation of this line? The equation of the line is y is equal to 2x plus 3, right? So when we plot all these points, it is along a straight line. The equation of this line is y is equal to 2x plus 3. Okay. So since it is along a straight line, the points are along a straight line, no? So that is the reason why it is called as a linear polynomial. Linear, the word linear, from the word linear we can able to see it is the line, line. It is a straight line. So that is why it is called as the linear. So linear means line, line. So the points are along the straight line. So that is why it is called as a linear polynomial. Okay, fine. Now we can able to observe that this line y is equal to 2x plus 3, it is crossing the x-axis. It is intersecting this line 2x plus 3. So this line 2x plus 3 is intersecting the x-axis. This is the x-axis. It is intersecting the x-axis at this particular point. So what is that point? That point is minus 1 by 5. This point is minus 1 by 5. So this point is called as the 0 of the polynomial. This particular point, it is called as the 0 of the polynomial, 2x plus 3. So that is the solution for this line y is equal to 2x plus 3. Wherever it is intersecting the x-axis, wherever the line is cutting the x-axis, that point is the solution. So what is the solution here? X is equal to minus 1.5 is the solution, or I can write it as h is equal to minus 3 by 2. So that is nothing but the same solution which we got here. So this is about the geometrical meaning of the polynomial. Okay, wherever it is cutting the x-intercept, wherever it is cutting the x-axis, that particular intercept, it is called as the 0 of the polynomial. Fine. In the following problems, we will do many more graphs and try to understand. So one more point is that this line 2x plus 3 is intersecting at only one point. It is intersecting x-axis only at one point. It is cutting the x-axis only at one point. It cannot cut at 2 or 3 points. It can cut, since it is a line, it cannot cut, it can cut only at one point. So hence it has only one 0, that is h is equal to minus 3 by 2. Fine. So now I want to make a note, is that for a linear polynomial p of x is equal to ax plus b, that is the general form of the polynomial which we know. Ax plus b is the general form of the polynomial, general form of a linear polynomial. It intersects x-axis exactly at only one point, and that point is p of minus b by a comma 0. So what is the coordinate of this point? What is the coordinate of this point? The coordinate of this point is, okay, the coordinate of that point is minus 3 by 2 comma, along the y-axis it is 0. So what is minus 3 by 2? Minus 3 is the constant term. Minus 3 is the minus of constant term. So what is the constant term here? 3 is the constant term, minus of constant term is minus 3, that is what present here. 2 is the coefficient of x term, 2 is the coefficient of x term, coefficient of x. Okay. So, for a general polynomial ax plus b, it intersects at x-axis exactly at only one point, p and that particular point is p of minus b by a comma 0. Okay. So, this 0 is the meaning. So, this 0 means that the point p is intersecting at x-axis. So, having understood the geometrical representation of a linear polynomial, now we will go on with the geometrical representation of a quadratic polynomial.